Okay, we want to calculate the determinant of this matrix by row reduction to upper triangular form. So, first thing we do is we switch the third and the first rows so that the third row is already consistent with upper triangular form. Naturally, the first row also is. Okay? When we switch two rows, that multiplies the determinant by -1. Then we add -1/7 of the first row to the second. And, no, I'm sorry, we take 1/7 of the first row, okay? And I'm just going to do that multiplication, and that's very straightforward. Then we add negative the first row to the second, okay? So that's going to give us 0 here. 3 is 21/7, we subtract 4/7, we end up with 17/7. And 4 is 28/7, subtracting 8/7, we have 20/7, and our last row is still 0, 0, 8. This is upper triangular form, so the determinant is just the product of the diagonals. And you can see that just by expanding the determinant on the first column. The cofactors you get here and here are going to be 0. So the only cofactors you get are these, and everything works out because, well, yeah, the minor you get here is upper triangular, so you're going to get nothing from this diagonal, you just have this diagonal, and that builds back to the fact that you have the product of these three diagonals. So your determinant is 1 multiplied by 17/7 multiplied by 8. That's the determinant of this matrix. Now we want the determinant of this matrix, so our first operation multiplied the determinant by -1. Second operation multiplied the determinant by 1/7. The third operation didn't change the determinant. We'll say we multiplied it by 1 because adding a multiple of a row to another row doesn't change the determinant. And then that's times the determinant of this matrix, which is 1 times 17/7 times 8. And we can multiply all that out. I believe we end up with negative. Denominator is going to be 49 because you have 2 7s in the denominator. And 17 times 8 is 126. If I did that multiplication right, 80 and 56, yeah. Wait, whoa. 80 and 56 would be 136, wouldn't it? Anyhow, do the multiplication correctly, and that's all that's necessary for that problem.